Are you ready?
Yes.
Yay. Okay.
You guys can see that?
Yes.
Okay.
So hello, everybody who's just joining in. We're just going to wait a few minutes to make sure we have everybody, give people a chance to join. Just to let you know, if you're not very familiar with Zoom, you do have a chat feature on the bottom of your screen. If you click that, you'll be able to kind of talk to each other and mention things, make comments. And then there's a Q&A feature as well that will have you use to ask questions of the speakers once they get started. So again, we'll just wait a few more minutes and then we will get started. Susan, I think we can begin whenever you are ready.
Okay. Was that me or somebody else? All right, well, I am Susan Berta with Orca Network. We are really excited to have our third Orca Month webinar. We are sorry we can't all be together celebrating and working together personally for Orca Month this year, but really are thankful for Zoom and these technical advances that can help us be together as best as we can. I wanted to start by saying also that we aren't charging for our webinars. We're providing them free, but as always, we can use your support to help pay for the software and for the educational work we do. We, along with many other businesses and nonprofits, are taking a hit from the COVID epidemic, and so any support is appreciated, but we are happy to provide this for free, knowing that many of you are also affected. Given all that our country and the world has been going through recently, we did want to start first by acknowledging that all of us, no matter where we are on ancestral or present lands of Coast Salish or other indigenous peoples, and want to acknowledge and honor them for their generations of knowledge of the natural world. And I am heartened to see more inclusion of Native American representatives in the environmental movement and conferences, and the credibility given to their ancestral knowledge of our lands and our wildlife, fish resources, because they know more than any of us. And I feel like science is finally starting to embrace that more than in the past. So I just want to acknowledge their generations of knowledge and experience that they bring, and all that they continue to do in to help with stewardship of salmon, orcas, the ocean, and the lands that we are all inhabiting. I also wanted to ask for a moment of silence, given all that we are going through with the racial inequality in our country, and being thankful that this is being brought up, and voices are finally being heard, and would like to take a moment for all of us to just think about that. And one thing we've been thinking about is how can we engage a more diverse audience in the environmental work that we all do. So I'd like you to join me in that, as well as thinking about the many, many people we've lost to COVID-19 around our country, around the world, and all the families who've been affected either by the loss of a loved one, by the loss of a job. There are just so many things that have been really intense for us. So would like to just take a moment of silence to think about those things and honor those people. Okay, thank you for your thoughts and prayers and for honoring that along with us. We're very happy to have you all join us. The series of webinars has talked about a number of things and covering the different issues that the Southern resident orcas have had to deal with over their generations of life on this planet. Today, we're going to talk about ocean noise. We're really thankful and honored to have representatives from two organizations that Orca Network has partnered with for a long time. Scott Veirs from Beam Reach and OrcaSound. We've been very excited to have Scott's work with the hydrophones and enabling us to get our hydrophone push point set up, and we're hoping to get another one set up. and also his help with our orca listening booth at the Langley Whale Center that's been very popular. And much of the other work he does on sound and working on some exciting new apps we're hoping to get going soon. And then Washington State Ferries, we've partnered with for a long time, decades, doing naturalist programs, working with them on whale sightings, working with them to get sightings when they're doing pile driving for redoing their docks. And we're just really proud of them for the environmental work they do and their assistance in sharing whale sightings. And that's been a great win-win partnership. So we're really excited to have all these wonderful people here today to share their knowledge and what they've been doing for the orcas. And we start with Scott Veirs from Beam Reach and OrcaSound. All right, Scott.
Thank you, Susan. And thanks for the introduction and the invitation to participate. I'm in Seattle and I'm excited to see all of you from Orca Network and also Washington State Ferries and talk to all of you today through a webinar. I've got a slide deck I'm going to try to go through pretty quickly, but to give you an introduction to ocean noise in the Salish Sea, and with a attention to how it affects southern resident killer whales. But as I share my screen here, I should also say that, you know, as chair of the Marine Mammal Work Group for the Puget Sound Ecosystem Monitoring Program, we should keep in mind today that there are lots of different animals, marine mammals and other marine organisms that are affected by noise. And so let's not forget them today. But I'll definitely focus mostly on southern residents, one of which is pictured here in front of the Chelan Ferry. And I guess I want to start today by playing, you know, one of the greatest hits of OrcaSound. This was a recording of what southern residents sound like that was made in Harrow Strait near Roche Harbor. So that was a good example of some calls and the other signals that southern resident killer whales make, which are clicks and whistles. If you'd like to dig into these slides, which I'm going to go through pretty fast here, so you can find these slides at orcasound.net/talks. And feel free to drop questions into the Q&A as we go, and I'll try to respond to you. Generally in bioacoustics, the study of sound used by life and made by life and affecting life in the ocean or on land, bioacousticians talk about zones of impact. So just like human ears, we can, you know, noise or very strong sound signals can cause injury all the way down to just being audible. So in terms of the impacts of noise, the closer you are to a sound, generally the more injurious it could be to you, or how it may affect your behavior increasingly depending on how close you are to it. But these zones that I'm mousing over here also can grow and shrink based on what's called the source level, or how intense the sound is when it's first created. So in any given situation, these zones may be very large, like could be hundreds of meters or kilometers between each of these, or if it's a very faint sound, you may not even have some of these inner zones. You may just have zones of audibility and behavioral response. But sort of going through the levels of seriousness of the impact, we can start with injury, where you actually can get killed by sound. because it shears apart the tissues inside your body as the sound wave goes through you. So that can cause trauma. And in some animals, that injury can kill you directly or lead you to kill yourself through, say, a stranding event. Then there's deafening, which in acoustics is referred to either a temporary threshold shift, so a temporary change in how sensitive your ears are, or a permanent one, like a permanent deafening. So that can happen to humans at a concert. And then behavioral change is sort of a more subtle impact of noise. And then below that is masking, which just means interference of the noise with signals that you're trying to listen to with your auditory system. And then below that, we're all familiar with, chronic noise. It may not be interfering with your ability to communicate, but it definitely can stress you out. And finally, there's just the zone of audibility. And if you get far enough away from any sound, even if you have very sensitive hearing at a particular frequency, you won't hear it anymore. So thinking about these zones from southern residents, I'll just quickly say that we have good evidence that killer whales are southern resident killer whales respond to noise, and I can talk a little bit about that. We don't have great evidence that they've ever been directly injured or killed by noise, but there are some cases like L112 and J34 where the animals through necropsies appeared to have died from some sort of blunt force trauma, and so we shouldn't rule this possibility out. There are some sounds like underwater explosions or military sonar that could cause acoustic trauma to killer whales if they were close enough to them. We haven't had southern residents strand because of noise as far as we know, but we certainly have observed that in other toothed whales, so that's also in the realm of possibility. And then deafening, I'll just quickly play a few sounds for you. These are the types of sounds that occur occasionally in the Salish Sea that could cause a permanent or temporary threshold shift. And luckily, we have some experts today who talk about pile driving. This is a recording of what's called sheet pile driving that was made out in Nia Bay. Sort of like hammering on a piece of metal. This is a recording of a Canadian naval vessel that was recorded in 2012, just 6 days before L112 stranded on the outer coast of Washington. It's echoing through the Harrow Strait that was recorded also near Roche Harbor. And then this was on the same night, a detonation that preceded the sonar. So this is probably about 10 kilometers away from our hydrophone. All of those sources of sound are, if you're within meters of them, are certainly strong enough to temporarily or permanently affect your hearing. So behavioral change, I'll get to in the next slide, and masking I'll talk about. But I want to just highlight that in some cases, which are analogous to what we're going through right now, there have been times when shipping noise has decreased for marine mammals. And one example was right after 9/11, when right whales were under study before and after that traumatic event, and there was a observed opportunistic and lucky observation of decreased stress levels in the period after 9/11, when shipping and airplane traffic had all been halted for a period of days. So we may, if the southern residents come back during the COVID experiment we're doing, we are confident that there's much less boat noise in their environment right now. So hopefully we'll get some samples and be able to publish a similar study for southern residents. In terms of behavioral change, maybe the most dramatic example in response to mid-frequency sonar was the case of the Shoop in 2003, when conveniently the southern residents were in Harrow Strait when the Shoop entered Harrow Straits using sonar that sounded like this. And that sort of ping, or pulse of tones from the sonar, that was repeated for a long time, and it happened to be observed by Ken Balcom right in front of the Center for Whale Research. So this picture was taken by Ken, and it shows the southern residents doing what those of us who have watched them a lot don't see very often, which is almost all the animals in the pod stayed near the surface with their head in the top meter or so, and that's a part of the ocean where you can shield yourself from intense sounds by getting your ears and your hearing system close to the surface. So that kind of made sense to us, and it was certainly from Ken's perspective a dramatic change in behavior in response to that noise. A more subtle response is, this is evidence of the best evidence we have of masking. A study led by Marla Holt showed that these are decibel levels and underwater decibel levels. It just shows that as the background noise goes up, which she attributed mostly to nearby whale watching vessels or fast moving nearby recreational vessels, the killer whales were raising their voices. So this is the source level of their calls versus the background noise in their environment. And it just shows that if you raise the noise by about a decibel, they raise their voices by about a decibel. This is what boat noise sounds like. That's a fast-moving boat passing the hydrophone. Well, that last two slides really, I just want to mention that killer whales don't hear the same way that we hear. They have and they also make signals well beyond the frequencies that we can make signals at. So this is just a scale of frequency or hertz, and we hear well between about 20 hertz and 20,000 hertz. But killer whales, both their signals and their clicks, their calls and their whistles, and their actual hearing system is measured in captive killer whales, have power that overlaps with our hearing range, but extends well above it, up to about 100 kilohertz. And they hear best at 20 kilohertz, where most of us don't hear at all, especially as we get older. So that's one thing to mention. And then one thing I've specialized in, and I think we should all be worried about for southern residents, is in terms of chronic noise, is the noise from ships rather than boats. Commercial ships like tankers, bulk carriers, and then all the way down to tugboats and fast-moving recreational vessels, I think, are all of concern. The reason we think that ship noise is concerned is this plot here. It's just called a power spectrum. So frequency is across the bottom, and then the level we measured at our hydrophones is in the vertical scale is black. The blue lines show you what natural or background levels look like. So this middle one would be the median background level, and the black ones are the noise levels when ships are going by. So the middle of these black ones is the median ship noise, and you can see that the median is well above the background at all frequencies. So this is important, and you can read our paper to learn more about it. But when you hear a ship like this, mostly it's polluting the environment at these low frequencies, like 50 hertz, that matter a lot to humpbacks or gray whales or minke, but are almost inaudible to southern residents unless they're really close to a ship. But up at where killer whales hear well is here at 20 kilohertz, and there's even at these very high frequencies that we can't hear at all, the ship is elevating the environmental noise level. So this is why we were concerned about ships, even though they sound like low rumbly noise sources, their noise does overlap with the hearing range of orcas and can interfere with their signals. In some cases, we get really squeaky ships that have a lot of power in these middle frequencies where killer whales communicate, and these may mask not just the echolocation clicks, but their communication signals. Luckily, that ship has been taken out of service, but I'm interested in working towards ways that we can remove those loudest ships and keep the quieter ones. Oh, I'm not going to go into the detail of the modeling efforts that suggest that this ship noise does matter for southern residents, but various approaches over the years have shown that the loss of the communication space that the killer whales use to communicate is about 2/3, or at least maybe 2/3 to roughly 2/3 to 3/4 when a ship is passing by, and up to 95% for the space that they normally would have in which they could echolocate successfully. So last thoughts on ships, they clearly dominate. They're probably responsible for about 2/3 of the acoustic impacts on killer whales, southern residents. And there's about 20 per day going through this core summertime habitat to and from the ports of Vancouver, Seattle, and Tacoma. But boats do matter as well. We know that they elevate the noise levels during the summer relative to the winter. The good news is that if we look at the power spectra, the median power spectra for all these different types of ships here, we see that they're all pretty similar. So if we can quiet any type of vessel, that will be helpful. And they all the other thing that's you can see in our paper is that they all have a lot of variability around these median levels, which means that there are quiet vehicle carriers and noisy vehicle characters, and the same goes for all of these classes. So it just means that if we have lots of opportunities, if we could quiet if we could remove just the noisiest 15% of the ships, we would cut the pollution in half. We could also quiet ships in every class and accomplish a halving of their pollution. Speed limits also work and have been tested by the Canadians recently. And we could develop a noise threshold and talk about also keeping all ships below that threshold as a way to cut the pollution in half. So that's the good news. There's a lot of variability and a lot of technologies that we can use to solve the problem. So I'll end just by saying thank you to all of you who've listened over the years, and we're excited to try to add some more hydrophones in the next couple of years. And please listen when you can to live.orcasound.net, where since this is Orca Action Month, you can now take action and tell us when you hear something as you're listening. So, thank you. I'll stop sharing my screen at this point.
Does anyone have any questions or are you continuing, Scott? Or you?
Oh yeah, no, I was going to hand off to the next speaker, but I'm happy to take questions now.
Yeah, let's see if you have any questions from anyone out in Zoom land.
There are a few questions in the chat. One of the questions was, can audio trauma stem from harmonic vibration?
Yeah, so if a sound is tonal and causing what's called resonance, that can cause more damage. And most of the sounds that we're talking about, like today, pile driving and is not really, doesn't have a lot of that sort of steady tonal property. Some ships have that, but most ships, they sort of sound clickety clackety, and they have a lot of power at different frequencies. So they're not, there are tones within that, but they, except for that squeaky ship, most ships don't have a lot of that that type of sound, probably the military sonar is most likely to cause some sort of resonance at a particular frequency or harmonic that could be damaging more than a non-tonal sound.
Thanks, Scott. Another question was, have you looked into propulsors?
I haven't myself, but I know that those have been used. They've been discussed recently when the Southern Resident Killer Whale Task Force looked at ship quieting technologies. So yeah, there's shrouds for propellers. There's actually different types of hubs where the propeller attaches to the shaft that decrease cavitation. And those are all good for killer whales in that, you know, the cavitation is the source of that high frequency component of the ship noise. So you know, changing the mechanical source of propulsion, like switching from I think we'll hear a little bit about switching to electric power, might not affect the propeller part of the noise, but it probably will decrease a lot of the lower frequencies that often cause low frequency tonals or vibrations of the ship hull.
All right, another question. Does slowing down the big ships and smaller boats make a significant difference?
So it definitely, the Canadians have done a great job of measuring in collaboration with our colleague Jason Wood, that slowing ships down does decrease the average noise level, let's say in any given month. So it definitely decreases the noise pollution intensity. And that's a good thing. It does also increase, you know, the duration that there is noise in the environment. But so the good news is that for most ships, if you slow down to the Canadian speed limit of about 11 knots through the water up in Harrow Strait, you are dramatically decreasing the noise level that the killer whales might experience outside of the shipping lanes. We don't want really, you know, there was a sort of a fixed speed limit when they first ran the trials, and they've been changing the speed limit, increasing it a little bit. Generally, I think if you should slow down as much as you can, because if you only slow down a little bit, you don't decrease your noise intensity very much, but you do decrease the duration. You increase the duration because you slow down, and so you're in the environment for longer. So we should be careful that as we keep exploring slowdowns as a mitigation method, that we don't inadvertently reduce the quiet time, which is probably important for Southern residents. It may be during the quiet times when they can hear the faint echo of their click coming back from a Chinook salmon 100 meters down in the darkness. And if they can't hear that click, they don't that echo, they may not know to begin to forage, to make the effort of diving down deep. So it's a great question, and I think it deserves some more research, but we should all be aware that, you know, slowing down, if you are going to slow down, even in your own powerboat, slow down as much as you can.
Okay, one more question. Would you say that naval submarines have had less impact on the overall noise pollution because their screws have been designed to reduce cavitation so much?
Yeah, that's a great question. Absolutely, I would say that. I know that we've never heard a screw that anybody has recognized of say a submarine coming past Bush Point or the Port Townsend hydrophone out of the base in Hood Canal. But the Navy did ask us to please keep our hydrophones on the edge of Puget Sound and not put them closer than, say, a few hundred meters to the middle of the channel, because you know, those vessels do still have a signature. They've done a great job of quieting the cavitation noise of especially submarine propellers. And I hope that Navy Region Northwest will continue to reach out to the Southern resident conservation community, as they did it most recently last October. They attended a workshop that was discussing ship noise. And so there have been two NOAA-sponsored conferences over the last, I guess, 2 decades, which were focused on how to transfer naval quieting technology to the commercial sector. I think it's time for another NOAA-sponsored or DFO-sponsored discussion, but I think Navy Region Northwest clearly has expertise both on the engineering side and the acoustic side that could help solve the problem. I'm not sure the trick will be how do you get the commercial industry to move? Like, how do you get them to decide to change?
All right, thanks, Scott. I think that is all of the questions. So we can move on.
Yeah, should we go on to Adrienne Stutes from Washington State Ferries? And then she'll be followed by Rick Huey. Thank you, Adrienne.
Thanks, Susan. Let me just try to share my screen here and get going. Okay, there we go. All right, well, I want to thank Orca Network for asking us to join in on this webinar today. My name is Adrienne Stutes. I'm a marine biologist with over 15 years experience working in the private and public sectors in Washington State. I've been with Washington State Ferries for about 2 years, working in the Terminal Engineering, Environmental Sustainability, and Stewardship program. My work primarily involves doing biological and environmental permitting for the terminal maintenance and construction projects. But I'm also more recently getting involved with the sustainability efforts with Washington State Ferries, specifically those surrounding marine mammal protection and stormwater. So let me just get this into the right mode here. There we go. Okay, so sorry about that. So I will continue just a little bit, some of what I'm going to talk about will feed a little bit off of what Scott talked about first. I'm going to focus on some of the work that Washington State Ferries is doing to help mitigate impacts of vessel noise on marine mammals in the Salish Sea. So we'll start with just a short background on Washington State Ferries, just give you an idea of the extent of what we do. First of all, Washington State Ferries just celebrated its 69th anniversary operating in Puget Sound in the San Juan Islands. We maintain 22 vessels that operate on 10 routes, which results in 19 terminals and 1 maintenance facility in Eagle Harbor on Bainbridge Island. Washington State Ferries services approximately 24 million passengers per year and moves approximately 10.5 million vehicles per year, which translates into over 160,000 sailings and over 900,000 miles traveled per year. So as you can see, this could result in lots of ferry traffic in the Salish Sea, and the need for Washington State Ferries to be aware of and attempt to mitigate for the noise impacts on southern resident orcas and other cetaceans and marine mammals that are found in the Salish Sea. So I want to focus today on a recently completed vessel noise study, a marine mammal management plan that we're developing, whale report and the whale report alert system, whales in our waters, and Washington State Ferries safety management system as it pertains to SRKWs. And finally, I'll look at the ECHO-like program that's being developed in Washington, and we'll explain more about that later. So in 2019, Washington State Ferries contracted with Noise Control Engineering, which is a subsidiary of Gloston, to conduct underwater noise testing and analysis of 9 ferries on 3 different routes within the Salish Sea. And by doing this, we were able to obtain data on all size classes of our ferries. And the purpose of this study was to measure and assess and understand the underwater radiated noise characteristics of our ferries, to identify potential injury and harassment impacts, and to identify primary causes of radiated noise and potential mitigation strategies for each ferry class. So hydrophones were deployed along 3 different routes near Seattle, Anacortes, and Port Townsend. And they were deployed for, I believe, about 8 days in each scenario. Vessels were asked to use different operating systems each time they transited directly over the hydrophones to correspond to different shaft RPMs for all vessels and different propeller shifts or pitches for vessels with controllable pitch propellers. And sort of the short version of the results of this study showed that in all cases, noise levels were reduced when vessel speed is reduced, but this varies between the vessels. So also differences in the vessels had to do with whether they were diesel-driven engine or diesel-electric engine, and I think Scott touched on that a little bit. I'm not going to discuss that too much here, but that is certainly one other factor that they were looking at with this. So using the data that they generated, noise control engineering was able to calculate some of the permanent and temporary threshold shifts for cetaceans. For this study, potential hearing impact zones were developed using guidelines similar to those that we use to calculate noise impact zones during vibratory pile driving. That's sort of a lot of the data we have and that we're able to use. And we also thought that the noise generated by a vessel is likely similar to that generated by a vibratory hammer. The vibratory hammer sound is a little bit different than what you heard in Scott's sheet pile audio that he presented. That is an impact hammer, so you do hear that chunk, chunk, chunk every time. With a vibratory hammer, it's a much more consistent lower level sound that lasts for as long as the hammer is on. So it's thought, as I said, it's thought that the noise generated by a vessel is similar to this vibratory hammer sound. So potential hearing impact zones for cetaceans ranged from around 15 meters at the lowest to farther out, depending on the vessel and the operating conditions. The primary noise sources for each vessel include propeller cavitation, which we heard a little bit about, propulsion motors, and gearboxes in the vessels that have those. So we definitely saw a clear correlation of noise with propeller shaft RPMs and pitch. In order to reduce noise, a reduction in propeller cavitation will need to occur. And there are various methods that may be used to reduce propeller cavitation. And that's something that Washington State Ferries will be exploring to see if we can make this happen and see what's viable to happen with our boats. You know, how difficult it would be to retrofit vessels that we already have or change the design of vessels that are being built. And hopefully by doing that, we can decrease the behavioral zone somewhat. So this effort I'll discuss a little bit more in the Marine Mammal Management Plan section of this talk. So move on to the next slide. I am actually in the process of drafting a Marine Mammal Management Plan for Washington State Ferries. WSF is a member of Green Marine, which is a voluntary environmental certification program for the North American marine industry. It's a rigorous, transparent, and inclusive initiative that addresses key environmental issues through 13 performance indicators. And one of these performance indicators is underwater noise. And one of the criteria for meeting the underwater noise performance indicator is the development of a marine mammal management plan in order to reduce the potential adverse effects of vessels, especially within known sensitive marine areas. So as I said, I'm currently in the process of developing that plan. It will include a discussion of the impacts of underwater noise on marine life, current regulations, or possibly lack thereof, marine mammals potentially present where vessels are transiting, and mitigation measures and best practices. So as this plan is developed, it will become part of the operating procedures for our ferries. And so, you know, we are looking at lots of different things to put into this plan. And as I said, we're in the process of drafting this, and hopefully it will be out later this year. So Washington State Ferries is also active in using the Whale Report Alert System and the Whale Report app. And we also use these in conjunction with reporting sightings to Orca Network. So it's something we do all together. RAS was developed by Oceanwise in British Columbia, and last year was extended to include the entire Salish Sea. Commercial mariners, including Washington State Ferries, can obtain real-time sightings of southern resident killer whales in their vicinity and act immediately to slow down and or change their route to avoid the whales. The Whale Report app can be used by anybody in the general public to report a whale sighting immediately. And once that sighting has been verified, it's then inputted into the Whale Report Alert System, where it can be accessed by commercial mariners. So this is something that Washington State Ferries vessels in operations use currently to report sightings and to track the presence of southern resident killer whales in the Salish Sea. And we can also use that information to let Orca Network know that these are out there and let them broadcast that as well. So it really is something that we can use quickly and easily and let everybody know that there are whales out there. A recent example of this tool, of the use of it, occurred a few weeks ago in Rosario Strait. People on a pleasure craft just out in the strait spotted whales and reported that sighting using the Whale Report app. The sighting was then uploaded to RAS, and a tanker transiting Rosario Strait was able to slow down, decrease its noise, and avoid the whales. Without that sighting being inputted into RAS, it's likely that they wouldn't have been able to slow down soon enough to make as much of a difference. So we think that this, in conjunction with Orca Network sightings, is likely to have an impact on southern resident killer whale recovery. So that's something we're really pleased to be using right now. Washington State Ferries also employs a safety management system that employs safety guidelines and features for all of our ferry operations. One aspect of the safety management system is that it employs a more conservative approach to managing impacts to cetaceans. Rather than simply applying southern resident killer whale regulations to just southern residents, we apply them to all cetaceans. That way we can ensure that all whales are protected and there hasn't been a misidentification between southern resident killer whales and transient orcas, for example. Secondly, we have begun training all of our new vessel crews using whales in our waters training. And this is a training that was developed by the ECHO program out of Vancouver, BC. It trains folks in the identification of local whales and provides suggested navigation strategies when encountering them in the Salish Sea. The plan at Washington State Ferries is to eventually train all of our vessel crews. And you know, we've discovered that this is really an excellent training for people to use to get to understand the southern residents and other whales and to be more aware of their likely presence in the Salish Sea while they're out on vessels. So I've put the website up on the slide here for EchoLearn for Whales in Our Waters. It's a training that's available to anybody who's interested, no qualifications necessary. So if you're interested in learning even more than you already do know about whales in our waters in Salish Sea, this is an excellent training to look at. And finally, I'd like to take just a few minutes to discuss the ECHO-like program that is being developed in Washington. The development of an ECHO-like program in Washington ultimately came from a recommendation made by Governor Inslee's Orca Task Force. ECHO stands for Enhancing Cetacean Habitat and Observation. It was developed by the Port of Vancouver and has been operating since 2014. The program currently being developed in Washington will build off of the successes of the ECHO program to maximize efficiencies. It will be a voluntary, industry-led effort that will be made up of private, public, and nonprofit sector partners. The hope is that it will promote voluntary compliance and will employ best available science. So more to come on this as the program develops. Washington State Ferries is part of the team that is developing this program. So we will obviously be involved in it. So I know this has just been a brief introduction to some of the things that Washington State Ferries is doing to try to mitigate for vessel noise in the Salish Sea. We still have a lot of work to do, but we're constantly evolving and learning and striving to do better. And I'd be happy to answer any questions.
All right, thanks, Adrienne. So far I see two in the chat. The first one says, is RAS used for all the other marine mammals besides southern resident killer whales?
Yes, it's used for all cetaceans, I believe. But what happens is when you report to RAS on the Whale Report app, you do specify, let me see, I'm trying to think. I think you do specify the species and it will show up that way on the map.
All right, awesome. And I've got another question here. It says, first, I want to say congratulations and thank you for 69 years of service. What I want to ask, though, was when your current fleet eventually retires and when the technology becomes more readily available, have you considered using jets as a propulsion for your ferries, increasing efficiency, speed, and reducing noise?
That's a great question. I'm not sure that has been thought of or discussed. Really, our focus right now is to convert to electric, which should also bring the noise levels down, we hope, as well as being more fuel efficient. But I'm not sure that jet propulsion has been discussed.
All right, if anybody has any more questions, I can unmute you if you want to ask in real time, or if you want to go ahead and put them in the chat. That's another place to be able to ask Adrienne some questions, so we can leave that open for a second. Otherwise, I think we're going to move on to Rick.
Any other questions? I also wanted to mention that we will, at the end, open it up for all questions for everybody as well. Okay, but if there's no further questions, then we'll move on to Rick Huey, also from Washington State Ferries.
Great, and thank you for giving me the opportunity to talk today. I'm a biologist with Washington State Ferries. I've been with them for about 14 years now, and I primarily work with endangered species and marine mammals. So spend a lot of time thinking about marine mammals, and today I'm going to be talking primarily about pile driving. So let's take a look here. So a little bit of background. I know all of us have seen ferry terminals, of course, but it's good to be aware of the different structures and the different kind of piles that may support those structures. So we're taking a look here at our Kingston terminal, and we see the different offshore structures called dolphins that help guide and secure the vessels when they leave or come in. This particular terminal has overhead loading, which is supported by large shafts, and the trestle itself is supported by piles. And in this photo, we can see that there's a barge and a crane in doing repair work at the terminal. Elevation view of these structures, a different terminal looking out the transfer span where the cars drive from the trestle onto the vessel, the towers that raise and lower the transfer span, the wing walls, and the dolphin structures, in this case, supported by steel piles. So again, ferries and ferry dolphins and wing walls guide the vessel into the slip and provide stability while the vessel offloads our loads. And we do occasionally get hard landings, like you can see on this wing wall here. So why do we do pile driving? Sometimes we're doing seismic upgrades to make the terminals come up to current seismic standards. We replace damaged structures, like in this example. And we're also doing new and upgraded terminal construction. And I'll give an example of our Muckleteel construction later. So the types of piles include timber, primarily in our older structures that are gradually being replaced. Something called a steel H pile that I'll show a picture of here soon. Sheet piles, steel pipe piles, and then piles also can be made of concrete or plastic. And a drilled shaft is essentially a very large steel pipe pile that is commonly used to support overhead loading structures. And then in the San Juans, we occasionally use micropiles because of the bedrock that's present. So timber again, common on older structures. We no longer use creosote treated piles, and at every opportunity we remove those creosote treated piles from the environment. And so we can use timber as a temporary pile when we're doing construction, but those timber piles would not be treated with creosote. There's a newer treatment called ACZA that is still allowed in marine waters, though we rarely use even those ACZA piles, except when we need to match up timber for timber in our older structures to help support those. But recently we've moved to using H piles in some of that repair work. So here's an example of an H pile. You can see the photo to the right. It's supporting underneath a wooden trestle. So we would make a hole and drive the pile through our trestle and then repair that hole. And so that's one of our newer fixes for wooden structures that need additional support as the timber piles start to deteriorate rather than using timber piles. And these piles are vibrated in, and we'll take a look at the different methods of installing piles here in just a bit. Steel sheet piles, commonly used in bulkheads. They're not all that common at our terminals. We do have some. Steel pipe piles are most frequently used. They can range from 24 to 36 inches in diameter and usually have a 1-inch wall thickness. Concrete piles, rarely used, but we have used them in some portions of our new Coleman terminal rebuild. And plastic piles are commonly used in dolphins to replace the timber piles that are damaged or failing. And again, drilled shafts, very large pipe piles, 6 to 8 feet in diameter. And we use those because hydraulics are placed into the shaft when they're finished, and those hydraulics raise and lower overhead loading in order to match up with the level of the tide so we can have our passengers walk on and off at a comfortable level. So the installation methods for piles include both vibratory hammer and impact hammer. So this is a picture of a vibratory hammer. We use this most often. It has less harmful noise than the impact hammer, though it does create a large behavioral zone in many cases. And we're not required to attenuate that noise because it doesn't have the large injury zones that impact driving can. For impact hammers, we commonly use a bubble curtain, and I'll show an example of that here in just a bit and talk about it. So let's take a look at a vibratory hammer installing an H pile. And there's that continuous noise sound that Adrienne was talking about. And then the impact hammer. So when we need to have a load-bearing structure, we need that pile impacted or proofed in order to measure the load-bearing capacity. So this does require noise mitigation. Impact hammers are a little more difficult to handle. You need to, of course, be lined up and vertical, and they do require the use of a bubble curtain to attenuate noise. So here's an example of an impact hammer, and you can see down at the bottom here the bubbles from the bubble curtain. And that does attenuate noise roughly anywhere between 8 to 12 decibels, depending on the situation. And there we go. So there's that impact noise. So two types of bubble curtains, unconfined and confined. So the unconfined are more commonly used. Confined are for when we're doing what are called a batter pile, a pile that's angled and driven with an impact hammer, though those are rarer than plumb piles or vertical piles. So here's a look at what an unconfined bubble curtain looks like. 3 rings attached to a compressor. And this drives bubbles, air through the rings, the bubbles come out, and those bubbles actually capture a certain degree of noise and quiet the pile driving. Example here of placing the curtain over the top and the bubbles turned on, like we saw in the previous slide. An example of a confined bubble curtain was it's essentially a larger pipe pile over the pile with material on the inside to help prevent the sound to transmitting out beyond the confined bubble curtain. Certainly some sound does get out, but they're obviously would be much heavier and harder to manage, so they're not used quite as much as the unconfined bubble curtain. And then demolition techniques. So when we're removing a structure, largely we use a vibratory hammer to pull those piles out. And in some situations, when we get enough piles loosened up, we're able to use a cable and pull directly without any noise being produced by a hammer. And then on some occasions, like we see over on the right, we pick up bits of, in particular, timber piles that might break due to their age from the bottom. Just a quick look at a pile rig with a vibratory hammer. The spuds which anchor the barge, usually with an accompanying equipment barge. And so now we're going to talk a little bit about when we pause work and shut down during this pile work. So we mentioned earlier, we're primarily focusing on southern residents today, but we pay attention to all the marine mammals out there on our projects. And we pay attention to endangered fish species and the marbled murrelet, which we see in the top photo here, an endangered seabird. We go through a variety of permits and approvals. So not really to go through each one of these. I tend to pay attention to the last two bullets. So Endangered Species Act and the Marine Mammal Protection Act, the ESA listed species that we pay attention to are humpback whale, SR killer whale, and marbled murrelet. They're designated critical habitats. We pay attention to essential fish habitat and all the marine mammals, including the non-ESA listed. We work to protect all of them. So fish can include salmon steelhead, rockfish, green sturgeon and eulachon, which are rarer. Of course, the southern residents, humpback whale, again, the marbled murrelet, and then a variety of non-ESA listed marine mammals. And depending on which terminal we're at, north or south, some of these are more common in certain areas. Most common are the pinnipeds. We're seeing more northern elephant seals than we have in the past. Pacific white-sided dolphins, more common in our northern terminals. Minke and gray transient killer whales. Harbor porpoise and Dall's porpoise. And in my time at State Ferries, we used to see more Dalls and fewer harbor porpoise. And that seems to have been reversed now. We're seeing far more harbor porpoise and fewer Dalls. So again, we monitored during pile driving or removal at all of our projects. Here's a crew at our Port Townsend terminal preparing to go out and monitor for marine mammals and make sure that we see everything that might be coming our way and pause work when appropriate. So here's a photo at our new Mukilteo terminal with new piles that have been placed. And so one thing we're doing is we're stopping work for all southern residents, even as they approach our behavioral zone. And I'll show a figure in a bit here to give you a feel for how large that could be. We record all of our sightings in ArcGIS Survey 123. Especially for our large projects, we have multi-year projects where we have thousands of sightings. So recording all of that data on paper would be very difficult. So this also allows us to drop all of the data we've collected into ArcGIS and produce maps showing what we see on any particular day. And this is again is the Mukilteo area. So as part of the Mukilteo project, we removed the Defense Fuel Supply Point wooden pier, very large creosote pier. And here's a video that's going to go very quickly. So you can see there's the demo equipment out in the center. They've already taken out the center of the pier, and they're going to move offshore and then come back and pick up some timber from the bottom and then move inshore. Here we go. Working offshore, taking the timber down. And moving back in. And they'll come back and finish the inshore piece. And that's it. So that, with tank farm removal, excuse me, I'll get back in the show. There we go. So here's a figure. You know, we use the NOAA models to try to predict how far noise may go. And these are very conservative models. So this is for steel vibratory pile driving. And you can see that the model says that the harassment zone may go pretty far up Camino Island from Mukilteo. And the inset here are smaller potential injury zones depending on the hearing frequency of the marine mammal. So for these potential injury zones, we'll do shutdowns for harbor seals, for California sea lion, whatever marine mammal might come close enough to potentially be injured, we'll stop the pile work until they clear that zone. For the larger harassment zone, for the southern residents, if they would approach that very large zone, we again would stop that work. If we are confident that the orcas we're seeing are transients and not southern residents, we would be allowed to continue work and do limited harassment. So we work with Orca Network and NOAA to make sure that if we see orcas, we try to know who they are. If we don't know if they're transients or southern residents, we behave as if they are southern residents to make sure we don't make a mistake. You can see the binocular symbols are just where our different observers are placed. So we also use our ferries, which are great viewing platforms for observers to get out on the water and high up above the water for monitoring. We're also lucky enough to have been lent the keys to the Mukilteo Lighthouse for this project, and we have an observer in the lighthouse during work. So here's a quick look at what we have seen at Mukilteo the last construction season. Quite a lot of harbor seals. A lot of these observations may be multiple observations of the same animal. Again, northern elephant seal, California sea lions, some stellar sea lions. We've seen the southern residents 34 times. Transient killer whale, 15 individuals. Humpback, just once. The grays, of course, we know are present in the Mukilteo area, but usually not in the work window that we work in, which is August 1st to February 15th in general. And again, harbor porpoise, fairly common. Quickly want to talk about creosote removal. Like we mentioned, we're trying to remove all toxic creosote out of our system at the ferry terminals. And by 2021, we estimate we'll have nearly 24,000 tons of creosote removed from the Salish Sea. And 24,000 tons is about the weight of 16,000 Priuses or 4 of our biggest ferries fully loaded. And that is my presentation. And I'd be happy to take questions.
So if anybody has questions, you can write them in the Q&A. I'll check the chat as well, but the other option you have is there's a way that you can virtually raise your hand if you'd like to verbally ask your question. So at the bottom of your participant list, there should be a way for you to raise your hand.
Well, I have a question for Rick. Interested that you're seeing more elephant seals, and I saw you saw several around Mukilteo. Our stranding network has been following very closely a family of elephant seals. The mother, Ellie, came to Whidbey Island more than 10 years ago, and she has now had 3 pups that were born on Whidbey Island. The oldest is Ellison, a big male who comes back every year to haul out on the east side of Whidbey, up like toward off of Freeland, I guess. Then her second one, Elsie May, who is several years old now, and she hangs out up at Skyline Drive, also spent some time at Camino Island State Park. She is very social. She's been tagged, so if you see a tagged female, and especially if she loves people, it's just bizarre. So she causes a lot of trouble, especially up in the sky. But then the mom had one more pup, another female this year, Eloise, who is gone right now, but she was born on the west side in the spring, but she was attacked by a coyote a couple nights in a row. So we moved her. She's healed from her wounds, but if you see a young elephant seal with some wounds to her back flippers, that's one of our family. But so we would be interested in if you're able to share any of your elephant seal photos when you see them, because we kind of track, we're waiting for the male to come back. It's about time he leaves for a while and then comes back. So we've just been documenting them for 10 years because it's the first known elephant seals being born on Whidbey Island. So we know at least one elephant seal that's contributing to the increase in sightings. That just would be interested if you can share that info, and we can share pictures of our little family, and just be interested to see if they hang around.
Yeah, we'd be happy to have our observers contact Orca Network on the day we see these animals. So we have lead protected species monitors that are in charge at each of our big projects. And so I could talk with them about communicating to you and getting that information over.
Okay, that would be great.
Also, for those that are curious, this is a ribbon seal that visited our area a number of years ago. A visitor from the far north. Pretty rare, but at least it found some snow and seems happy in the snow.
All right, we do have a couple more questions, one in the Q&A and one with a virtual hand raised. So I'll start with the Q&A first, and then we'll unmute the other one. So the question is, where do the creosote pieces go?
Yeah, creosote is disposed of in landfills that are qualified to take that kind of toxic material. So we'll have our contractors use best management practices to put those on a barge in a manner to where all the creosote and the material that would come off of it is contained and covered from the rain. And then they will take it to a qualified landfill. They will give us the landfill tickets to prove it's been disposed of properly. And we keep those records and make sure that we check all that before the contractor is given the okay to be paid, essentially. So it's one of the requirements of the contract that it be properly disposed of.
All right, I'm going to go ahead and unmute so this person can ask their question verbally. Go ahead and introduce yourself.
Hi, my name is Liam Doucette. I live a few hours away from Puget Sound. I actually live in Portland. And I was wondering, would you say that piles which have been screwed into the seabed have more support rather than piles which have been hammered into the seabed?
Yeah, I think the question was, there is a technique where piles can essentially be rotated as opposed to vibratory pile driving, which liquefies the sediment and pushes down on the pile. I know that rotating technique has been used in Japan and I believe in San Francisco in some projects. We've not used it at Washington State Ferries. Our contractors have not proposed that technique. So I wouldn't really be able to say if rotating the pile into the sediment is more secure or not, or more load bearing or not. I think it would take an engineer to answer that question.
Okay. One more question I want to ask is, when you do drive the piles into the seabed, do you have another something on that goes over the pile to anchor it in place, or do you just hammer it in and the platform is just then rested on top of that?
Yeah, it's the second. All these piles are driven in to be very stable. We like to build to last 50 years unless they're damaged. So whether or not it's a load-bearing structure or one of our offshore dolphin or wing wall structures, all of these piles are completely self-supporting. And then the template and all the items that go on the top of the structure are welded on and tightened together.
All right.
Can I jump in on that first one, Cindy?
Sure.
I'm not sure if it's what you meant, Liam, but when you were asking your question, I imagined a really different type of pile from the tree trunks that we decided were the most useful way of making things stand up in the water. But what I imagined you asking was whether if you had a pile that you could screw in, like a corkscrew, would it be more or less stable than a pile that you had hammered in?
Yeah. Yeah.
So that if that's your question, that's a very cool question that maybe still would require an engineer, but I thought you might enjoy that reinterpretation, Rick. You made me imagine, like, what if there was, like the things you screw into your lawn to anchor the leash of your dog in the backyard. It's that kind of idea, but that could then be retracted, leaving the pile in place, having like pulled it down. Or maybe it's just permanently part of the pile, which obviously be more expensive. But as somebody, I started in oceanography thinking about marine geophysics, and I I wonder if maybe one of the problems is that if you disturb the mud, most of these areas are muddy bottoms. And so I guess there's two engineering questions that maybe you can address, Rick, because if you disturb the sediment by like screwing down into it, does that make the pile less useful and stable? Or is the mud just too fluid on the bottom of the ocean to really grab and allow the screws to grab enough to push, I guess it's actually pull the piling down into the sediment? Very cool question, Liam. You got me thinking hard.
Yeah. So one thing I know is that, we use geotechnical reports for each of our terminals, and we'll make sure to drive until we're down in hard sediment beyond the mud layer. And sometimes we drive to as much as 40 feet below the mud line. So we'll be down often in very hard material. And when we need to have a load-bearing structure, that's often why we have to impact to get deep enough into that hard material to make sure that pile is stable.
Yeah, because I was thinking like if the piles were screwed into the sediment, depending on if the sediment can support it, depending on if they were screwed, would you say that wouldn't it technically be easier then to pull it out once eventually they've started to deteriorate over time? Because when you remove a pile that's been driven into any kind of soft sediment, don't you have to deal with suction building up around the pile as it's in the dirt?
Yes, and in particular, those piles that are driven deep into hard sediment can be very difficult to remove with a vibratory hammer. There are cases where it's been impossible to get piles out, and they're actually cut and abandoned below the mud line, and then that depression is filled in. The location of that pile will be noted in our as-built records, so that particular spot we won't try to drive a pile on top of that old pile remnant. But our preference is always, when we're taking piles out, to completely remove them, so we have all of that ground available to do our work if we need to do additional pile work at the terminal.
Right. Yeah, because I was thinking like when screwing a pile into the dirt, be more structurally sound than just hammering it and being easier to take it out, because you wouldn't have to leave it in the sediment.
Right. Yeah, I'm afraid I don't know the full answer on that, but if I know if you Google, I'm not quite sure exactly what they call that technique, but if you Google, you'll probably be able to run into some examples, I believe, at a San Francisco Transit Center, and some examples from Japan. And I think there were some videos showing this technique in action, how it's being done.
All right, cool. Thank you.
Thanks, Rick. And Scott. So the next two questions I'm going to kind of combine. They're along the same lines. One of the questions was approximately what is the lifespan of the steel and plastic pilings versus the wooden structures? Do they last longer? And the second part of that would be, are there any concerns about the plastic piles eventually shedding microplastics because of all the concerns about microplastics in the water?
Yeah, so in general, steel piles have a longer life than timber piles, though it's been surprising at times when we've removed creosoted timber that's sometimes up to 40 or 50 years old. We'll cut that pile into sections for disposal, and many times the piles are in very good shape. So back when they used creosote and they used a lot of it to preserve that timber, it worked quite well. Of course, it is toxic and we don't use it anymore, but it really depends on the particular pile and the location and how the creosote treatment was done in those piles. But we do believe that steel will have a longer life. Steel does need some maintenance. They're coated, so they resist salt water. And when that coating gets abraded, it needs to be repaired. So we do constantly check all of our terminals and determine where maintenance and repair is needed on piles and other parts of our structures. And could you repeat the second part of that question, please?
Yeah, it was, are there any concerns about plastic piles eventually shedding microplastics?
You know, I don't have a good answer to that. I do know that when we rub up against those plastic piles with a vessel, they certainly can get damaged. And I would imagine that some material is lost into the water. Exactly what that material looks like, is it in particle size or larger pieces, I'm not really aware of. I do know that in general, when we say plastic, it's not the normal household plastic. It is, these are high molecular weight plastics that are meant to resist pressure. So, and it's the same as the flat panels you might have seen on wing walls. So those are all high molecular plastics, and they're probably less prone to damage, but certainly they can be damaged.
All right, thanks, Rick. So it looks like all of our questions for you specifically are wrapped up as far as me just browsing the Q&A in the chat here. But we wanted to give everybody an opportunity, if they missed it the first time, to ask any of the three of you any questions. So we can use the hand raise feature again to ask that in real time. We'll go ahead and unmute you if you have a question for any of our speakers. Or the chat, or the question and answer is still open if you want to type a quick question in there that we could get on board for one of these three. And Liam, did you have another question? Oh, no. There we go. Your hand was still up for a second.
I think it's back up again.
Okay. So Liam, if you have another question, go ahead.
Yeah, I do. And it's for, is it Mrs. Stutes or Miss Stutes? Or
Adrienne's fine, thanks.
okay.
Yes.
One thing I wanted to say, I was a person who asked about the propulsion thing. So one more thing I wanted to ask was that, as well as switching out, your power plant, since you're gonna try and get your fleet to move on to just using electricity, because doesn't your fleet right now use diesel electric?
Yes, that's correct.
So yeah, going back to the whole propulsion thing, have you also considered redesigning the propellers to reduce cavitation, seeing how that's where a lot of the Orca are hearing those sounds? It's from the propeller spinning.
Yeah, and so I think that's something that is being discussed as a possibility. I'm not sure that any decisions have been made about that, but I know it's been thrown out there. So certainly we know that cavitation is an issue, and figuring out exactly how to best deal with it is something that's still being worked out.
Okay, all right, thanks.
I have to keep asking a related question, Adrienne, which is, I've ridden the ferries a lot up in, mostly because my parents are in the San Juans, and most of the I think all of the ferries that I've been on are double-ended, and so they have propellers at both ends. And I think I understand now that the forward propeller is not engaged in propelling at the bow when it is at the bow. But I guess I wanted to ask you as well, like, if that's the case, and the big question is, like, theoretically, could we move to a ferry design that's really much more efficient and aimed at going one direction? Because my sense, just from walking around on the car deck, is that a lot of the clackety part of the noise from Washington State Ferries is coming from the bow as opposed to the stern at any given moment.
Yeah, that's a good question that I don't necessarily have an answer to, being a biologist rather than a vessel engineer. I don't know how easy it would be. The way our terminals are designed, the way our vessels are run right now, is to have a double-ended vessel. I don't know. Rick, do you have any thoughts on that? You've been around ferries so much longer than I have.
Yeah, so you're right. You know, that currently we have that double-ended vessel. It makes it more efficient for going, you know, port to port, and it allows us to avoid, you know, backing out and turning, and then heading out again, and making that part of our transit, which could impact schedules.
Yeah.
So that's one thing to consider. We of course, you know, have the double bridges. So when we go the other direction, the people in the top cabin are moving to that new cabin, and off we go right back. So it makes it quite efficient, but it does mean we have that bow propeller. But you know, as we move toward design for our new vessels, we're not only looking at going electric, but we're looking at all the other kind of things we could change that would help with noise reduction. And so that's going to be part of our design coming forward in the future.
When I was finishing in oceanography at the UW, we got the Tommy Thompson, which was amazing to watch it dock, because it would come into the Marine Sciences building in Portage Bay there, and then just sort of start moving sideways. So you know, the idea of backing a Washington State ferry up to the receiving dock in order to have the cars go off in the right direction seems terrifying at first, but I think with bow thrusters, the current technology might allow you to spin that thing and back it up, just like you can your car.
That's an interesting idea. I think we'll be talking with our vessel engineer, designing vessels.
Yeah, and corkscrew pilings. It's been a very, very active day, in my opinion.
Yeah.
Well, I have a question for the ferries, since we're talking a lot about pilings. And this goes back, 15 or 20 years. We were working with Tony France from Whidbey Island, who is the person who single-handedly made people realize how toxic creosote was. And he invented a machine. Well, he had several machines he invented to more safely pull piles and to suck up the toxic, the creosote that might still be in the sand around the pulled up pilings. And he had, several different things that he worked on and he actually is the person who got DNR started on removing creosote logs from beaches. He's actually been sickened by creosote because he's been a deck builder and was, felt the effects of the toxicity, and he's an orca lover. So he did a lot of work, and I don't know if any of those ever made it into use. I haven't talked to him for a number of years, but I know in the early days when he started, there was just a lot of resistance because, creosote's everywhere and it's what we use. And like Rick said, it's what really, helped the wood pilings all around, be useful and stay in use. And when we didn't have other alternatives. But I just wondered if you had heard of any of his work or the machines that would help kind of vacuum up. I think it was like a casing that went around the piling and would take up the toxic water from around the pilings so that it wouldn't be dispersed into the environment.
Yeah, I believe I've heard of him, though those techniques are not commonly used. One thing we do is we pay close attention to the turbidity level around the pile that we'll remove. There's often a curtain around the work area, so we collect any wood shreds that come off the pile. And when the pile comes out of the water, we make sure that the contractor is not shaking the pile to let that potentially contaminated mud adhered to the pile fall off into the water. It used to be common where they would actually kind of wash the pile before they put it on the barge in order to get rid of that mud. And now we require that anything that sticks to the pile goes to the landfill out of concern for it being contaminated. But those are the best management practices we commonly use for creosote timber removal at this time.
Great, great. Yeah, I know he's still, was in the development stage and was bought by a company, but I don't know if they've made the, the machines to do that on a large scale yet. But it's good to see how things have changed, and so much creosote being taken out and replaced by other materials.
Amanda, if there's time for one more question, I have one for Washington State Ferries.
All right.
Okay. One thing that Michael Jasny got me thinking about with respect to L112 and J34s was whether we could ever tease apart which Southern residents may have some hearing loss, either from something recent, like when I've been around, or when you've been around, Rick, with pile driving, or even further back into when explosives were used to herd whales during the capture era. And then he got me thinking even back to the earlier stage where there may have been military interactions with the whales before the capture era, or fishermen. So with that kind of like decadal, even century scale lens on thinking about the Southern residents, do you think that before we had marine mammal observers and like pre-1970s, even like ESA legislation, do you happen to have, like, I don't know, any historical pictures that might suggest that the Southern residents could have been exposed to pile driving during, I guess I'm thinking Washington State Ferry pile driving, but it could be any dock building activity, I guess.
Yeah, I'm not aware of any pictures specifically showing, say, a pile project with whales in the background that could document that.
Yeah.
But no question that that they were present, and likely present in a noise zone produced by a port project or an older ferries project. Mm-hmm. So, timber, while timber can be impacted, it doesn't have the same interest quality as a steel pipe pile being impacted.
Right.
So, so there certainly could have been effects. Those effects may have been smaller, but the requirement and the awareness to shut down when animals come close probably wasn't there at all.
Right. And so were piles, like back in the early 1900s, were all those creosote piles driven in by some sort of cool hammer system?
Yeah, I think impact hammering timber piles is the common technique. They use what's called a pile cap between the hammer and the pile in order to not, take the wood apart too much. But impact driving is still, and I think has been for decades, the common practice for those piles. And then vibratory for removing.
Right. Well, it's hard for me to imagine the Southern residents kind of getting surprised, like being right next to a pile driving operation when they happen to start up, and being damaged by, and being only like 10 meters or 100 meters from that first impact. Seems like in most situations they would be well aware that pile driving was happening and could easily avoid the area just because they hear it as they approach, right?
Yeah, and for our current projects, we'll do pre-monitoring. We'll monitor the area a minimum of a half hour before we start pile driving. And if they're present within the behavioral zone, or if another animal's within an injury zone area, we simply don't start until it's clear.
Sure. Yeah.
We also use what's called a soft start technique. It's a few taps with an impact hammer or a few vibrations with pauses to kind of give everyone a heads up there's going to be noise in the water.
Right.
A little unclear how effective that is, but it's one of the requirements, so we certainly do it.
Thank you. Great answer.
All right, so Let's see here. Liam, I don't know if you have your hand up for another question or if it was left up from last time. But I think we're going to make this the last one so we can get wrapped up. So I'm going to allow you to talk here if you have a question.
Yeah. So, Rick, have you considered lining some of the piling with, or just covering the surface with covering the surface of the piling with metals like copper or brass or something that doesn't corrode in water very quickly, or something that just doesn't oxidize that much to reduce damage?
Yeah, we certainly use what are called coating systems. They're not commonly metal. They're almost a very thick marine paint that diffuses very little material off into the water. So before piles are put in, that coating system will already be in place, and they'll be installed. And then as those piles are damaged or scraped, at a certain point when it's bad enough, we'll come back and divers will actually apply coating material to repair those areas to try to protect that pile. And I do know in some cases at certain terminals for older steel, we still use some, I believe, anodes to help prevent, rust and so on. But that seems to be less common. These new coating systems seem to be primarily what we use to protect steel piles.
Okay. All right. And Scott, actually, I remember going back to the whole thing about cavitation and trying to convince companies, to start adapting that technology that the Navy has. Could you tell them about cavitation also causing damage to their ships? Because over time, bubbles will start to break down the edges of the propeller blades, that can cost a lot of money to fix.
Yeah, that's a great idea, which I hadn't really thought about that. Encouraging one of the simple ideas is just to encourage a little bit more propeller maintenance, making sure that dings get fixed. And like that squeaky ship, when I've talked to ex-submarine techs about it, they often think that maybe it's wrapped some line around the shroud, or it's not the shroud, the shaft, or a propeller has been like damaged and is singing. So in that spirit, like getting it would be interesting to look like whether that's economically interesting to a ship owner or a shipping line. Thinking about, like, I think the propellers are very expensive, so that trying to get them to think about like what are the long-term costs of the cavitation, that's an interesting angle. Yeah, I think the retrofitting is tricky on big ships. It's all very expensive, and I think, yeah, I'm curious to see whether how that compares, like how something like a propeller maintenance period compares to retrofitting in the, like, taking out the diesel electrics. I mean, that obviously, as I'm sure Adrienne can tell us more, is it expensive both on terms of shoreside infrastructure and also the actual retrofitting. So just starting to get a handle on what are the real costs for different types of ships for each of these potential mitigations, sort of where we're at. And I hope it's part of the conversation of what Echo South really gets into, is a really detailed discussion of asking it that specific question that you asked, Liam, but for each class of vessel that's important in the killer whale's habitat.
Yeah, because I was thinking that when just maintenance costs just go down, having propellers which don't generate cavitation and therefore don't produce that damage. Yeah,
there's a similar argument. Like, you would think that since noise is a form of energy and cavitation is noise that occurs when the propeller is not necessarily operating most efficiently, that you'd see a direct correlation between fuel efficiency of the ship and the amount of cavitation. But still fledgling understanding is that's not always the case, that in some cases, the propeller can be cavitating and generating more noise, but still be operating in a hydrodynamic sense more efficiently than when it's not cavitating. So I'm honestly pretty confused by some of the results. Like the BC ferries have this sort of a bit of a counterintuitive result in that there is an optimum speed where if you speed up at a certain point, it can get quieter. But if you go much beyond that optimum, then it gets louder again. So each ship, it's tricky. I think the Navy probably, this is where they could really help us, is, you know, for each type of vessel, different classes of vessel, what's making the noise, and how is it connected to these sort of long-term costs like fuel or propeller maintenance and replacement.
Yeah, because their submarines, like the USS Navy, that nuclear submarine, its propeller is designed so that it can produce a lot of thrust at very low revolutions per minute. So
Right.
so it can stay quiet as well as giving a submarine a lot of speed.
Mm-hmm. Yeah, I think we all have a lot to learn about naval engineering, but folks at Gloucester, I know, are beginning to think about this, like just having it in the public eye that noise is important for certain species kind of drives not only the technology transfers from the Navy into the sector, but also just new thinking and measurements that will help answer questions like yours. I think it's gonna keep asking those questions, and hopefully we'll keep getting answers.
All right, yeah, thanks.
Okay, well, if there aren't any other questions, I think we'll wrap this up. I want to thank Rick and Adrienne and Scott all for joining us. We all learned a lot, and we really appreciate all the good work that you are all doing and have done for quite some time. And are just, the Orcas are lucky to have people like you working to keep them safe, and we appreciate that very much.
I just like to, Susan, just to add a thank you on that note, that we get a lot of reports from people on ferries saying the ferry slowed down or stopped and the captain announced there are whales out front, and people go out and see them, and that certainly benefits the whales. They get clear passage, and the people who get to see some whales go by. It may not help the schedule any for a little while, but everything else is fantastic. So many thanks.
You're welcome.
Yeah, thank you all for the work you do and for the opportunity today. It's nice to see you all.
Thanks. And I also wanted to remind you, we have 2 more webinars. We are today halfway through Orca Month. So June 22nd, we have our Orcas Are Hungry, with Dr. Deborah Giles from Conservation Canines and Orca Wild, and Monica Whelan-Shields from Orca Behavior Institute, who will talk about the availability of salmon for southern residents, which is one of the main issue that is causing them to struggle these days. Then on June 29th, we're wrapping it all up with a Spy Hoppy Hour, where you can join us with your beverage of choice. And instead of presentations, we're all just going to share favorite pictures, stories, videos, just kind of have a time for whale nerds and orca dorks to get together and talk about our favorite orca encounters. And we did our first webinar we did for our gray whale event in April, and we did a happy hour afterwards. And it was great to just, especially in these COVID times when we don't get to see each other much except for Zoom, it was fun to just have a time to chat and share stories and ideas. So feel free to join us for that. That should be fun. Also this Wednesday, for anyone who has any kids that they're trying to keep occupied, on the 17th, we are doing our Langley Whale Center youth activity via Zoom. So feel free to join us for that. And all of these are on our Orca Network Facebook event page. We also have recordings of all the webinars. We don't have the last one, or of course this one, up yet, but we will get those two up this week. So for those who missed the webinars or want to see them again, we'll have those posted on our website, orcanetwork.org, and they'll be on our Orca Network YouTube channel. And then on orcamonth.com, you can find the calendar of events that all of the Orca Salmon Alliance and other organizations, the events they're doing, and daily Orca bits of information. And we're just really thrilled to have so many people joining in on Orca Month these days, even though we had to do it virtually this year. It's been great. There's still a lot of action and learning going on, and all the interest from all of you out in Zoom land and beyond is what inspires us to keep going, and we really appreciate all of the public who wants to help. And last but not least, thanks to Cindy and Amanda for their great help with setting these up and handling the questions and figuring out all this technology that some of us are still struggling with. So thank you all for joining us.
Thank you.
Thanks, everybody. Have a great night. We'll see you
Yeah.
next week.
Stay
Bye.
well, everyone.
Hope you see whales out there.
Thanks.
Thanks.